That's the school.
Yeah,
This was addressing a student.
Not
like a juvenile delinquent. Juvenile delinquents can be students. No. Most of the time, those programs, they basically athletic.
Hey, real quick.
I actually have a question. What? Were you scared in there?
Mr. Ward, there are no hats in school. Mr. Ward, who do you think would win in the fight? You or Mr. Hat?
Not appropriate. Alright, hey, you need to have your graphing paper out. We're gonna go through a bunch of stuff today. So, sit, please. So,
What do you think we're gonna fight?
okay, alright.
He's like 7 foot.
Okay, so today what we're gonna talk about.
Oh, no, it's not this notebook.
Alright. Mr. Ward, do I need notes or just graph paper?
Notes, graph paper, you need a book.
Oh wait, are we gonna do like the SS 1.6 graphic?
Anything was doing it on his phone, like.
Okay, what we're gonna do today, we're gonna learn how to go through that more tough, complex problem where you can't just factor it apart, where we have to use that idea of the leading coefficient, that n constant, to actually do synthetic division and substitution. So today we're doing the really kind of more tough stuff.
Okay.
So we're going to be graphing. So we're still in this section 1.6 where we're graphing. And I just want to make sure everyone kind of understands how this works. Tomorrow we'll get homework. Today is about learning this process because we'll have a little bit of time. Homework we do next week.
How are we going to get homework tomorrow?
Friday. Ooh. Okay. All right. Here's the two problems I want to go through. So we got two examples, and these examples are going to represent how to do those problems that you can't just factor apart. So first example here that I want to cover, and we're going to put this on a graph paper as well, is this one. All right, so x to the 4th plus 15x to the 3rd plus 69x squared plus 65x.
That's long.
Minus 150.
Hey, that's odd, in case you didn't know.
And this is my function. That's the name of the function. All right. Goal today is to graph this to make sure we know the parts of them. I only have 2 problems to pick that I want to go through today. Once we're done, we're done. And I just want to go through that process of like where the tails go, how we're going to get, the x-intercepts, the y-intercepts, and how to go. And the reason we're going to put this on graph paper today is to get a feeling for how do we type it in a calculator, or how do you use like charts to get us more or less near the right decimals that we need. Because I can already tell you right now, the y-intercept is really far down. It's negative 150, right? So we know that this one's going to kind of go off the graph, but we know where it should finish. So, all right. So first of all, when we go through this, number 1, end behavior.
Same direction up.
Yep. So since the power is a 4, the tails are going the same direction. Tails go same direction. And that's because the even power. So if you need to write that down, even powers mean they go the same direction. The number that's out front means the tails are going up. Okay, tails go up because of that positive number in front. Positive leading coefficient. Okay, so tails go up. Next, we need to figure out where these x-intercepts, the y-intercepts. We already know the y-intercepts. So this is the part where we're going to need to do synthetic substitution or division, and we're going to try to figure it out. Okay, so we can figure out the y-intercept right now. That one's pretty easy. So y-intercept.
Negative 150.
Yeah, so because we plugged in zeros into all the x's, and when you did that, 0 plus 0 plus 0 plus 0, and it was negative 150, right? Those were the items that we had when I plugged zeros into everything, and so it is a negative 150. So that's way down there. Now, I'm not going to graph this yet. What this is on the y-intercept, this is the coordinate that we're hitting. We're passing through. we'll eventually graph this. We don't need to put it below the graph because these graphs we can jump by any margin we want. So we might renumber this to be like, maybe we'll jump by 20s or maybe we'll jump by 10s just to make sure we can get down to a point where we can graph and just to see kind of what this thing's going to look like. Now, to get the x-intercepts, you can't just factor this apart. It's not a grouping method. We can't do it like that. The reason why we can't do it like that is because these numbers are not clean. It's not like a third, like a cube root where you could group the first two and the back two together and then do it by grouping method.
You don't think that you could factor those ones nicely?
What?
No, I'm not going to be able to factor this like with our skills we have now.
Could you
So,
factor it with your
Eventually,
skills that you
yes.
have?
We will have the skills necessary that we can factor something like that.
Take a factoring class?
No.
Is that a
Okay.
extra credit class in college?
All right. So first, let's start with the tails. I forgot to draw that in the paper. All right. I'm going to have the tails go up. They're going the same direction. Now, we might have to modify where those are. Put those in a graph right now if you haven't already. Start with that.
Why?
Tails got to go the
I don't wanna do
up
it,
direction.
it's not gonna be in
So.
my area though.
The up direction.
I'll just do that bad.
Okay, next, we're going to try to factor, or not factor, but try to figure out the x-intercepts. So, we're going to do this with,
Positive one.
we're going to do this with calculators to make sure that we can find the numbers. So, what you do is you take the leading number up front, you take the back number, ignoring the signs, and you put the constant on the top, and you put the leading coefficient on the bottom. And then what you do is you break these up using all the factors. Now, I know 150 is big. If we at least, we're trying to find x-intercepts. So we're going to break this up to try to find some that work, or roots, if you will. Okay, so 150 is 1 and a 150, 2 and 75,
3 and 50.
3 and 50,
5 and 30.
5 and 30,
6 and 25.
6,
And
25,
15.
300.5.
and what do you say? 8 and,
Nope.
1.5 and 100.
What about
Yep,
what
10 and
about
15.
5,463
Cool.
702
That's all.
745
One.
7441?
Positive one numbers.
Alright, so we have all these numbers, they're plus or minus all these, and how this works is you take all these numbers, that's just the top, and you put these all over whatever the bottom factored apart. Well, the bottom's just a 1, so it's 1 and 1. But if the bottom was like a 12, you'd have to put like
What, 10?
1, 12, 2, 3, 4, 6. So you have to put all those numbers and then make
That would be
every possible
stupid.
Could
combination.
you do,
It'd be stupid.
for the bottom,
So.
could you do 2 and 0.5?
No, we're not doing that. We only stick with the whole numbers. Like they have to be integers, not rational numbers.
It's very
So,
close to you.
Wait, aren't integers rational numbers?
Integers are rational numbers, but I don't want the whole rational set.
Okay, you just want.
I just want integers or below. So, positive negative.
Positive one.
Now, okay, we checked, when we make every combination, we're going to check positive 1. I would check the small numbers first. Okay, so what you do, you take one of the numbers, if you're going to check it, you plug it into your calculator and you plug into all the x locations. This is called synthetic substitution. So synthetic, this is one method of doing this, synthetic substitution.
And you can just do it for every single one.
And you can do it for each one until you find
Or you
if
can
you
just
can.
not, just
I'm just going to do it for one because once I have one out,
Fail.
I can factor the rest of it apart. Or if I can't factor it, I'll go down to 2, I'll find 2 of them, and then go from there. So synthetic subs, when I do this, you're taking the 1 and you're plugging it in
So the 1 plus 15
to
plus
all of
10
these
65 minus
locations.
150 is 0.
Wow, thanks, we did know how to plug one into X.
I don't think you did. Obviously your D doesn't show you too bright.
Oh.
She got me.
Oh.
Hey.
Hey, this is a bully free
That
zone.
one's
Nice. All right.
Hey,
got me.
John fired. All right. So, all right. Well, we plug it in
Please.
and we get to 0. Right? We got to 0. Now, if you know that that one works, you have to now divide it out. Because what I want is what they call the reduced function. When I take out a 1 out of that thing. So if I want to divide a 1 out, I'm going to put it in the house. I'm going to do synthetic division across. You have to fill in any zeros or and negative numbers that you can. It has to go from the biggest power down to the smallest power of x's. And if there's anything missing, you have to fill in those terms. And we're going to divide it out. The reason why I need to divide it out is because what's left is factorable. So that's usually how it
Or
works.
you could
'cause-
keep filling things in until you found another one.
or you can do that and you can find another one.
Yeah,
Then
and you don't
then
have
you
to
can
divide.
divide both of them out.
No?
So, Question.
Just keep filling.
It's supposed to be a 15 out of
15. Thank you. Thank you.
Messed up.
Got me that.
You really would have confused
All right.
her if you hadn't called
Questions on the setup for what we did?
5. This is the last time.
Now, when we divide up, or when we do this, we drop the first number, multiply by the number in the box, drop straight down, multiply by the number in the box, and you would just keep going until we get to that point where 6 times 1, or 16 times 1 is 16. You add straight down, that's then 85. You multiply by the number in the box, you add straight down, you multiply by the number in the box, you add straight down.
I'll go with same.
Alright, there you go.
I'll go with 7.
And then do we put one back in it again?
Now,
Just
What?
okay, now, whatever we're left with,
No, you
it should be a
factor.
remainder of 0, because the synthetic substitution proved we get 0. That should be the remainder. Everything that's left, this,
That times x plus 1.
is
this, going up is what they call the reduced function. Now, where I'm getting these is you build up. This is the remainder. We know it's going to be 0. This is the constant x squared, x to the cube. And well, we know that has to work. It always has to be at least 1 less power than this thing. So that's because we're reducing it. We're going down 1 rung at a time. Now, you could do this whole process again. You can do the whole process, and you can see does it work, and you can try to figure out what numbers come out of this thing. And like, let's say we can't factor this thing. Like, we can't figure out what numbers come out to make the two match. Then we can, oh, is that, no, we're fine. So, question.
Do we have the factoring skills to do that one?
Okay, we do. If you want to try by grouping method, you can try to group up like the x cubed, the 16x squared. You group these up, and we see if we can break it apart. Now, will it guarantee? We do have the skills to do it, but is it guaranteed to factor? That's the big thing.
Yes.
Okay, so let's try it. So, on the first one, I'm going to take out x squared out of these two. So I'm left with x plus 16. Now what I'm hoping for in the back is I can take out a number here and get x plus 16.
5.
So if we take out a 5,
I don't know how that works out. I was just kidding.
Yeah.
Make
You
it
have to take out 85,
you're
but
going to
85
have
does
to
not
try
work.
to get it to match. 85 doesn't go into 150 perfectly. So
I said 5.
if we try to go any more, it won't match up perfectly here.
So we can't do
So
it.
we're not going to be able to factor this one right now. Now,
Not right
I
now.
said we do have the skills to factor those. Will it guarantee it? No. Because maybe that thing is prime, or maybe it won't factor apart. But what you have to do is once you get here, once you get to this point, then we start all the process over again, and we try the numbers for this problem again, because this is now reduced. So we try numbers for this polynomial that can work. Right now, this number worked. We know it. Positive 1 was one of the numbers that gave me 0 when I divided it out. So I know for a fact, we're hitting positive 1 on the x-axis. We already know that. You can put a dot right there right now.
Yeah.
We know that if you're going by ones. Okay? Which I'm going to. On the x-axis anyway. Now,
It's gonna be a negative number.
okay,
That
so
distorts the picture if you change the x. and
Yeah,
y,
that's,
so-
why would you
What?
change the x and not
If
the
you have the
y?
x as going as a certain number and the
you
y,
can have the x's go by a certain number, y's by a different number, you just have to label them.
but
Do
it'll
that.
distort the picture.
It'll distort, but it won't be, we're not trying to deceive people with like a random
I think
number.
we're trying.
We're just trying to plot the entire graph on it. So,
That's what this graph is.
alright, now,
Insider trading.
we have to factor out more numbers. So, if we try more, okay? Let's see.
I really just wanna know.
I'm not gonna type it in yet. Okay, have we tried another number?
Here, I'm trying one now.
Try 1, try -1, try 2,
No.
-2, 3, -3, 5, -5, 6,
I'm
-6.
trying.
It's gonna be something small. I picked some small numbers.
I already tried -2 and -3.
I'm not trying it all.
-1 doesn't work either.
Negative 5. Does that actually work? Try it.
Oh.
Insider trading.
I don't own a calculator this year.
Yeah, negative
Negative 5,
Go,
alright.
go, 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 go.
Okay, hey, here we go. Okay, we're gonna factor this thing apart. We're trying the -5 now. Alright, so -5 supposedly gave us a 0 in the synthetic substitution.
Supposedly, do you not believe me?
Or Jaden, at least he believed you for the one.
Theoretically
Yeah,
or
I said
literally?
Okay,
Is it theoretically or literally -5?
-5.
Or literally
There's
Okay,
alien life on the-
-5.
That was the dumbest question
What if
ever.
Mars has water? Because we live there.
Yeah, I know.
Okay, so we're dividing these out. we drop this number down, we multiply by the number in the box, drop that number straight down, multiply by the box. Add straight down, multiply by the number in the box, you get 0.
That is amazing.
Okay, so what we have here, this is now the reduced form again. So far it did prove that remainder is 0, so this number is one that works, so I can plot that one, that's -5. So -5 worked. So I have 2 x-intercepts so far, and what's left should be the other ones. So
17.
So we're gonna, this is x squared plus 11x plus 30, and you're right, if we break this up by factoring, because now we can factor this, it's 6 and 5 plus x and x. So it looks like this one represents -5.
It's gonna bounce.
So that was a double root. So that means
-5 dog break.
so -5 definitely bounce. Because why this is a double root? We already had -5 earlier.
Sorry. I just don't want you to stay like
This is a -6, so I'm going to put a dot there.
I bet you I know
I
what
like
that
this one.
is.
So-
I did it way back.
Passes through,
I didn't see
bounces
what
back,
you-
goes down.
Okay, so now we're starting to see where this thing's going to go. Okay, now all my terms put side by side. So all the x-intercepts.
Obviously, you're not paying attention.
So all the x-intercepts, I think I just want to go through this. So x-intercepts, that's x plus 6, x plus 5, and an x minus 1. So those are all the parentheses that worked. I'm just putting them side by side.
Even if it's gonna
That's
bounce
each
off
of
the
them.
x plus 5.
So x plus 5, this is definitely a bounce.
Just a day like
That's
tomorrow.
definitely about.
Did you
So
know that
pass.
if you did x to the 4th and you minus the 1, that means it's gonna turn times 3? Turn 3 times.
Yes. We're talking about the next. So,
Okay, well, I'm gonna
okay,
get rid of
we're gonna pass through this. Okay,
We're gonna pass.
so the powers told me if I'm passing through or bouncing, we know we're gonna be turning, say it again, Sid, how many times?
3.
3 times, so we'll take 4 minus 1, and now we're gonna graph this. And I'm just gonna do the best I can. My values here, I'm gonna jump,
Be careful.
I'm gonna jump by 20s, just so I can make sure I hit the -150.
Wait, 20 won't get
So
you
-20, -40, -60,
Oh, we're gonna be on an
-80,
even.
Yeah,
Oh.
we're not gonna have a line.
100,
Reese, that's one
20,
distorted image.
-140, -160. Alright, so we can get in between there, so, and then we'll go up by the same margin,
X plus 5.
20,
Is that a 5?
40,
Because if you plug in,
60,
yeah, that's a
80,
5.
alright.
I thought it was
So-
Why do you make lines for some?
Because if you plug in a -5 into that, it makes it 0.
Some are negatives. I can
Oh,
erase
what do you
those
plug
now.
into the x to make it 0?
Yeah, that's what I.
Negative.
Thank you,
Yeah.
Score. Or,
So -5 is
thank
not
you.
good.
Alright, so now, graphing this. We're gonna, so we're gonna pass through the first one. That makes sense, passing through. Somehow it's gonna turn around, we're gonna bounce off of this one. We're gonna go through -150, come back
That's
up.
negative 130.
Ooh, that is.
That is a negative
Ooh,
30.
I can fix.
That is an
I
accurate
can
graph, Mr. Ward, very
I can fix
accurate.
it, yeah.
There.
1, 2,
So,
3, 4.
pass through and then
That's
the arrow's
way too
going up.
many. Dude, you turned so many times.
Dude, it's okay.
1, 2,
No.
3.
1, 2, 3. I really don't
2, 3. What?
I
Please,
don't
pass.
understand the x plus 5 squared thing.
X plus 5
Because I thought you
squared.
got -5 and plus 5 is the thing.
No,
It's
no,
not?
no. This -5, the number that works. The
Oh.
parenthesis that represents it is
Oh,
parenthesis
negative.
x plus 5.
Say
I know, why did you
Cressy.
square that one?
Because
Google.
the later, so we checked -5 worked, that was one that Jane found, right?
Okay.
And we checked it, we divided it out, so these are the 2 that were left.
Do you have like
X plus 5 happened again.
No.
It was later, there was a second one. This is what
Is
we
it-
took out.
Oh,
It happened again, so that means there was 2 of them.
It's a duplicate.
I
So,
was-
it was a
It's
duplicate,
a
yeah.
duplicate.
It happened again.
It was a duplicate.
So,
It said duplicate.
alright,
Here, wait.
Just an
7.5.
okay. Now, this is the type of graph. We wanna graph this thing. We have to affect its viewing window. We have to look at a table set or graph. Now, I'm gonna try to show the graphing calculator here. I'm having a couple issues with the actual screen. I'm gonna see if I can fix this right now.
Have you ever seen the Angry Birds movie?
Have you seen the emoji movie?
Can I use one?
There's life in other planets.
Yeah, but not just like this one.
So, Let's see if I can show this.
What if there was that
Full screen. Alright, can I get rid of the graph?
Yeah, sure.
Alright, graph coming over here. I'm gonna type this in my calculator right now.
And you're gonna show us what it looks
Yep.
like.
Alright,
Wait, I think you should use that one camera thing again. That was fun.
Wait, what are you doing?
trying to get this thing to show up. but-
You
Click
can
on it.
click on it, click the Texas Instrument.
Wait, is this the most
Yeah,
expensive
click
one they
it.
make? You should show us the coolest one.
Oh, more.
I love
No,
how it's
click
still
on
pixelated.
the
I love how they still pixelate the two on a
On a
Let's
computer.
see if I can close that and then open
No,
it back
click
up.
on the Texas.
Oh,
Okay, let's open it back up. It's having a little hiccup with me throwing on the projector, does not like
a
that.
little hiccup.
It doesn't like that.
A big old hiccup.
Isn't that his mug?
Oh
What?
my gosh, I
That was my
cannot.
log.
Best
No,
user
see, it
has
does
one.
not want to show up here.
Best user
Okay,
has one.
that's fine.
It's the exact.
what we'll do.
No, this is
You can
the
just go on
one
Desmos.
that you had.
Oh, it is?
Yeah.
Alright,
Desmos would work.
okay, alright, here we go.
Okay.
Oop, oop, oop.
You don't wanna go
Some
to
tasty
Desmos?
coffee.
No.
It's practice, guys. Stop.
Stop playing.
No, alright.
Well, I'm.
Alright, so what I'm gonna type in first.
Dustin Ward. Changes.
Let's go second with.
It's so weird that I paid him.
But I guess you're
Why
signature.
does it not allow me to do
Sitting.
I don't know, but I think Desmos might work.
No, ready?
that? Second.
No, I already have a sample.
Why can't you give me these and dump them?
I totally still like it.
Where do you live?
I live in Garner.
Why would I give you an excuse?
Eh.
I know where we should.
Doesn't like what I'm
See,
doing.
I have a
Give me
sample.
a
Alright.
reason.
She has like 8 garages.
Anyway, let's hope that worked,
Desmos?
but it's definitely not
Get
showing.
five, I got
Only
6 jobs, I don't get tired.
I
3
tried-
people know the password to my storage unit that has $50,000 of Apple stuff in it.
Alright.
Me, myself, and
Take-
Alex.
Hey, there's this graphic calculator. Do you know what it's called?
Desmond?
Yeah.
Like email me?
Are you gonna use Desmos? Why
I'm
not?
just bypassing
Where
it.
are these?
One time you made me
Bye.
call.
Okay.
You really just don't want to do
3
it.
sets
No,
of
we're
where are
not.
these?
Why?
To ask her what
You only wrote an
wanted.
example. Oh.
Just I couldn't do that.
Because he was driving.
Alright,
And then we
last
were
one
meeting
today.
while he was driving.
Last one today. Here's what I like to do. In your little group that you're next to, or maybe you want to be a humble, I want you to figure out this next one on your own. And this is the one that I want to
Wait,
see
we
if
have all
you
this
can.
board room.
Okay,
Yeah, look at all this marker board
Can we do
space.
different groups on the board?
The amount of marker board space in this room is
You should number
insane.
your marker boards.
Astronomical.
Don't you think?
Or name them.
Recess on weekend.
Name them, Sheila.
Alpha, Delta, Beta, Charlie.
And they said, why do you think you have these on
Okay, here's the first one I'd like you to do.
I thought you said only 2 cars.
Yep, this is the second. This is your last one today. This is my function, we'll call this g of x, just so it's a different one. Okay, we're gonna go to a new graph. Okay, so I want to see the rough sketch of this thing on your graph paper. This is one that I want to do over the next 10 minutes or so. This one should be significantly easier than the last one because I'm not picking such big numbers. The constant in the back is 0 because they don't have it. But this one you can factor it almost right away just because of the numbers that are involved here.
Group it. Are you grouping it?
Yeah, we'll be able to do common factors first,
So, yeah.
and then a group method second.
Wait, does that mean the y?
It equals.
So that means the y-intercept is also an x-intercept?
Why? Yeah.
It's going the
Can we
same
use
way.
0 in the little house?
On the back.
Would that work if we put 0 in the house?
If it works, yes.
I don't know if it works.
So it's 1 over 0.
And then you can group it.
Options are limited.
It's not gonna work.
It's just 0.
Wait, I'll show you next time.
I don't know how that would work.
Why?
Wait, no, 0 is just 0.
0 is.
Guess you could just group it right away.
0.
Okay. I'll give you another 2 or 3 minutes here to see how you factor.
X.
See how you can factor.
Okay, so you can do X.
You can't group.
Forget.
Two groups?
You
can't.
Yes, you can group after you take out a common factor.
It's group.
What is the common factor?
Just say X. Just X. Unless there's an X on all of them.
Oh, you're doing that like that?
Take out, and then it's x minus 8, and then you will. You can take it.
Wait. Oh, yeah.
Now, if it doesn't group perfectly, at least you know one of your numbers right away,
Only an X.
one of your x-intercepts right away, so you can divide it out.
Are you giving us hints?
Intent.
Does the
I don't
x
think
just
you
mean
can take out a
0?
number for that.
Are you going to regroup?
Cause it's like 7.
Wait, hey, Mr. Ward, how spot on is
You
this?
can take out 3.
It's pretty good.
Oh,
Yeah, but I don't
But that
remember,
is
I don't remember what
not-
I did though, I took out an
It
X.
only has one intercept, doesn't it? Or is that
I
not
took out
enough?
X.
Does it have
Correct?
So it should be
I have
X minus.
No, but if you do the thing,
I think it's,
It's
we have to group it.
1 or 0 over
We
1.
can do like X.
And the only 0 over 1 that there is the 0.
So you have 1 right there. So that's
No,
1.
That's 1.
So you can take that one out. If you
And
know
I
that
already did.
I'm actually
you divide it out.
I don't know.
Wait, X squared and X
I don't know. 'Cause if
Alright.
you take a,
Hey.
let's just do it together.
Where are the tails going?
Up,
Okay, better make.
Up direction.
Okay, up. They're going the same
same. I
way.
think I could lift this up.
They're going to up direction.
Okay, they're going up. All right, now
Jacked.
one of the things that everyone's counting on is going through 0, 0. The y-intercept is 0. That means
So
you're
that
hitting
means
the
the
origin.
x.
So that's one of them. Now the reason why we know that, if this is my hint I was giving some people, you
take
can
out
factor out. You can take out a common factor. Well, when you take out the common factor, that guarantees you that
Whoa,
an
that
x.
needs to be a 2.
Whoa,
Whoa, that needs to be a 1.
Whoa.
Whoa, you're really gonna confuse people here.
There you go. All right. When you factor out the x, and it does factor out, this guarantees that 0 works. So as we factored out 0,
So stupid.
0 does work. It's guaranteed when you first look at it. That's one of the x-intercepts. Even though I know it's a y-intercept, because when you plug in 0 to all the x's, it gives you 0. But this guarantees that 0 is one of the numbers that work. I'm going to take out, I'm going to divide out 0.
Well, it
So,
kinda has to be.
this-
Because if you
So-
plug 0 into that, 0
Yeah.
turns
So
into.
if you do the 0 thing where you divide it out, this is what you'll be left with on the reduced function.
And then can we do the one thing to that thing
Okay,
too?
now you can do the same thing we just did on that last problem for this one right here. I'm going to do all the common factors of 18. So 18 is 1 and 18.
2.
2 and 9, 3 and 6. So these are all the numbers that multiply to give me 18. The number out front is a 1, I don't need to worry about it, it's going to be plus or minus all of these. So I would check these numbers next. I know 0 is one of them. 0 worked for sure. X plus 0, that's one of my functions, or one of my x-intercepts. But we can't check 0 again, we've already factored out 0. So now you've got to go after the
Plug
rest of
in
the
1.
numbers. So,
I bet it works.
say it again,
I said plug in 1.
plug in a 1,
I don't think.
plug in a negative 1.
2. Definitely 2.
I don't
He
think.
said
one
negative
works.
1, so that must be the answer.
Negative 1 might work, but 1 does.
Try.
It's 3.
Is it 3? 3?
Yes.
3, positive 3?
Positive 3.
Okay, 3.
Or you can
So we're gonna divide out a 3 right now. So we're dividing a 3 out of this thing. So that's a 1, -8, 21, and -18. Because we're gonna sometimes divide this thing out. That's a 1, 3, -5, 15,
Yo, 3
6,
totally does work.
18. That's a 0 for a remainder. So yep. So right now we know that x plus 3,
Negative 3, negative 2.
or x minus 3, I should say. Thank you. X minus 3.
Negative 3, negative 2 is gonna balance
So-
out negative 3.
So -3 is definitely one that works.
I
I
got
mean,
it.
I'm positive.
Okay, that one works.
No, it's positive
Then
3.
when we factor this
Positive
apart,
3.
No, it's negative.
It's
Positive 3, isn't it?
It's x minus 3. X minus
How do you
2.
get
Because it's.
so it looks like
Well, that
this.
should be plus.
It'd be negative 15.
Negative 15.
Isn't that a positive 3?
Yes.
Shouldn't it be
You wrote it
x
as a
plus
negative.
Mr. Ward, you put the 3 in the wrong spot on your graph.
Yeah. You're
Oh,
goofing me.
seriously. Oh,
You're
Mr.
goofing.
Ward.
Everybody's telling me.
I'm so-
Sorry,
I'm
sorry,
so-
sorry. I was looking at the graph, I was looking over here, I'm like,
Please.
that's
Why
not-
did it have 15 there's a negative 15?
What?
Sorry.
Thank you.
I did all the math in
I
my
was
head.
getting so
Okay,
confused.
sorry, Susan. Alright, so we got this, we have all my roots, these are all the roots that work. So it looks like positive 3 twice, so we're bouncing off of that.
Positive 2.
We're passing through 0, and we're passing through -2, or sorry, positive 2, passing through positive 2. So the idea is that it's doing something like this. It's coming through,
Passing.
it's passing,
Passing.
and it's bouncing.
Pass or fail.
And that's the absolute minimum,
Grease.
and that's the relative
I'm
maximum.
gonna do something like this.
So they're both, yeah, you're right. So the idea is that we have a absolute minimum,
Here you go.
we have a relative maximum, and we have another relative minimum.
Yes.
So Gus, you missed this one. This is relative min as well,
Why?
because it was another,
Well,
like.
you know, I was just pointing at the 2.
So, not bad. Okay, do we feel a lot more comfortable with how to graph these?
Yes.
Okay, tomorrow, we're gonna get a few homework problems. We might be outside
Not
the textbook a
tomorrow,
little
not
bit.
tomorrow, Friday.
Outside the
You
school,
outside.
there's so much marker board space out there.
And, yeah, you probably cried.
Mr. Ward, are you driving a convertible?
If I need to.
If I need
I'm gonna
Do
drive.
you have enough? Is everything lined up well or no?
Mr. Ward, how many convertibles do you
No,
own?
Or, me.
We have Kraus, Renee, we have Dargs, we have
Oh, I
Pritchard
thought
has
you were
one,
saving.
You have
Who's
mine.
only has
Billions
one?
has
Well,
one,
I know how much
Or
you
do
do.
you have mine?
and ours.
Well, it's not like they
ours.
are, they constantly can drop them everywhere. They can drop them.
We need
Six.
Wait, read
Ward's a liar.
You did not.
Darg,
Must, he said.
You would've said dark.
No,
Renee,
they
Denny,
didn't.
Kraus, Pritchard's, hopefully Billions.
Billions.
And then Olmer said they'll give us a Jeep,
How about Tori?
so, and what?
Jake's long, see that?
Perfect, so we have more than enough.
I don't know if his is for sure or not.
Oh.
Just avoid that one.
Well, we have enough.
That's kind of a touchy
The only one I'm not
subject.
happy with, it's not happy with, is that I don't wanna drive the Jeep. Just because we have to take the top off and if it rains, I don't know how to get the top back on in time. And it's not ours, it's a rental.
I have a question.
Okay, but that'd be sweet. A Jeep? I'd rather be cruising a Jeep.
Yeah, but
Hey,
I don't like the Jeep.
okay.
Wait, are we provided with candy or should we buy our additional candy so we can
You
throw it
just want
down?
me to give you the keys to when I come to this class.
yes.
I have a question. If you could be any animal, what would you be?
Would you be a honey badger?
Oh, that's how you
Honey.
do it. There you go, there's the,
Oh!
I just got the calculator.
Oh, so you gotta show us it, you gotta show us it.
Yeah.
Alright,
Show us it. Go, Kurt, I already like this.
hey, so give me,
Justin.
give me,
No,
X.
nobody's gonna do that, Ward.
I
oh, you erased it already.
will. Here, I'll show you.
I, Dustin Ward,
Susie.
that henceforth, therefore, moreover, may calculus pass.
Hi, nuts. It was 15, by the way. Then 16.
Hey, if all of us get 90% and above on our next test, can you make it pass or fail?
No.
Okay.
You all get 100%.
Dude, you think that I'll actually get 90% or above?
I expect